All right, this is Math 2, Unit 12, second semester final review. We're going to go over this worksheet. There are 3 pages to this unit itself. It's a lot on here. We did Unit 12 over the course of 2 different units. We had 12A and 12B. Before we begin, just a couple notes just to kind of make sure you get these in your mind as we go along. We're going to be talking about vertex, factored, and standard form as we go through this unit as a way of helping us graph things. The vertex form is when you have in the form of x plus something squared plus something else. Often these are h and k values here, so you'd have h there and k there. This value here, when you do the opposite of it, if you had a 2, for example, you'd have a negative 2, and that becomes your y value. Those become your maximum and minimum points. So the vertex is used to be able to quickly tell where my maximum or minimum would be for a graph, whether it curves up or curves down, one of those kind of types of things there, where those points would be. So that's what that's used for. If I have an equation in factored form, this tells me quickly where my zeros or my solutions are going to be. So if I have x plus 5, I take the opposite, and I have a negative 5. Opposite of negative 4 would be a positive 4. Just real quick, if I had something like a 2x minus 3, that would become a 3 over 2 as a solution. Again, I do the opposite, and I take that number as my numerator and that as my denominator. The way you actually solve that to prove that is you would say 2x minus 3 equals 0, and when you solve it, you would get that solution there. Our third form is standard form. We have the form of ax squared plus bx minus c. And then in this case here, this is used to quickly be able to tell where the y-intercept would be. That means when x equals 0, all that's left is that. And it tells you that point there. The standard form is what we would use to then use for the quadratic equation. Again, standard form is a squared plus b plus c. And knowing that, we plug that into the quadratic equation to find out any other solutions. Sometimes you can't take this and factor it out that way to find a solution. So you have to use a quadratic equation, negative b plus or minus the square root of b squared minus 4ac over 2a. To have a real solution, though, the number that comes underneath the square root needs to be positive. If it's a negative number, it's going to be an imaginary solution, and we would say there are no real solutions there. Another thing we can take a look at sometimes, if you have the vertex here, sometimes you have to find the vertex and it's given in standard form. The way we find the vertex is we use negative b over 2a. Again, starting with the standard form, I plug that in. That would give me my x value. Okay, so my x value is found using that. To find y, I would plug that in back into the equation to find out what y would be, and that would give me my vertex, if it's not already in vertex form. When we're looking at graphs, the domain is talking about how far it goes left or right with the x values, and the range is how up or down it goes with the y values there. There will be a couple questions on rate of change. A rate of change is when you take a graph of some sort. Let's say you make a t-graph or t-chart of x and y, and you plot out what happens at different points along the way, and you graph that. Sometimes when you don't have a linear equation, you have a quadratic equation, this slope changes dramatically depending upon the numbers you're using. So to find what that rate of change is, like let's say from here to here, we're basically talking about what is the slope from here to here as an average, even though it may be curves that way. What's the average going to be? To find that, you do the value of your y2 minus your y1 divided by x2 minus x1. And you create a t-chart to figure out what those would be, and that becomes your new slope in that space. A couple other things here. We're going to look at imaginary numbers a little bit. Just recall that I squared equals negative 1. So if you ever have an I squared, you can replace that with a negative 1. If you have a square root of negative 1, we don't want to keep a negative number underneath the radical. That becomes an I, and so you could take the negative out and put a an I out in front. You will have to be able to complete the square. To do that, again, you're going to look at the b value and do b divided by 2 and square that. That number, as we'll see in some solutions here, gets added to both sides of the equation when we move things around. So we'll go over that together in a couple samples here. And just recall, once again, the line of symmetry is where that quadratic equation makes its bend at, where it has a maximum or minimum value. That line here is the line of symmetry. Okay, so with that, let's go ahead and start. Again, there's lots of things in this unit. It was rather long, so here we go. It begins with saying graph f of x equals x plus 2 squared minus 3. This one, as we can already see, is in vertex form. Because it's in vertex form, I take the opposite value there. So instead of positive 2, I do a negative 2, and I move that one over by itself, no problem. Negative 2, comma, negative 3. So that's going to be my vertex point. So I can plot that at 1, 2, 1, 2, 3, and there's my first point of f of x. It's going to be right there. For this graph, because it is positive, right, in the number, there's no leading coefficient, but it would be just like a 1. Because it's positive, a positive graph is going to open in this direction, so we'd say it opens up. Okay? If it was negative, recall, a negative 1 would go down that way. So if you happen to have a negative 2x squared, that's going to be a negative, it's going to be a downward facing equation. In this case, because I have to graph it, I'm going to go ahead and make a t-chart, x and y. What I like to do, because it's a quadratic one, I already know that one point here at negative 2, we're already at negative 3, right? And I don't want to do a bunch of big numbers. So I'm going to use the values of negative 1 and 0 and 1 to complete my t-chart for a few more points. So when I plug negative 1 into there, negative 1 plus 2 is a 1, 1 squared is 1, and 1 minus 3 is negative 2. So I could plot negative 1 at negative 2, and then I mirror that on my line of symmetry, which is right here. I'm just going to mirror that across the line of symmetry. At 0, 0 plus 2 is 2, 2 squared is 4, 4 minus 3 is 1, I'm at 1. So at 0, I'm up here at 1, and again, moving over my line of symmetry, I put 1 there. When x is 1, our other value is going to be 6. So 1, 2, 3, 4, 5, 6, which means over here I'm also at 6. So my graph for this equation will look something like this, like that. So my domain, this is my x values, all the values of x. X, we can tell, is going to go all over the place. So we would say, in this case, all real numbers are my domain of f of x. For the range, how far up or down it goes, we have a minimum value here at negative 3. So y is going to be anything greater than or equal to negative 3, because that's where my minimum value is going to be. My line of symmetry is on this line right there, we already said, which is that x equals negative 2, 1, 2. And the vertex, sorry, is there a vertex, a maximum or minimum? Because it stops there, we would call that a minimum value. The next thing I want us to do is to graph on the same graph this new one here, negative 2x minus 4 squared plus 2. Again, the vertex value, I take that and I plug it in. It's the opposite of negative 4 is positive 4, and that becomes my y value of 2. So my new vertex is going to be at 1, 2, 3, 4, and up 2. This is my vertex for the second graph, g of x. So my maximum of g of x is going to simply be at 4. That's my maximum, be right there. My domain I don't know quite yet. I'd have to graph some points. So again, let me make a little t-chart. Here's x, here's y. I don't need a lot of points. I'm already starting at 4. So I'm going to go ahead and do one next to it and get smaller numbers, 3 and 2. When I plug 3 in there, 3 minus 4 is a negative 1. Negative 1 squared is 1 times a negative 2 gives me negative 2. And negative 2 plus 2 is 0. So at 3, 1, 2, 3, I'm at 0. And again, this is my line of symmetry. So I'm going to go ahead and just mirror that over to there at 0 when I'm at 5. 1, 2, 3, 4, 5. And when I plug in the point 2, 2 into there becomes 2 minus 4 is negative 4. Is negative 2. Negative 2 squared is 4. 4 times negative 2 is negative 8. Negative 8 plus 2 is 6. So we go here at 2, and we go to negative 6. Sorry about that. 1, 2, 3, 4, 5, 6 right there. And the mirror one is over here also at 6. So at 3 we're at 0, at 2 we're at negative 6. And so my graph for this guy looks something like that. Alright, So my domain, again, my x values are all real numbers, and my range for my g of x is going to be anywhere from, my y is anywhere from here down. So y is going to be less than or equal to 2, because that's the point at where that crosses there. My line of symmetry on this one is going to be at 1, 2, 3, 4 at x equals 4 is my line of symmetry. And the question wants to know, is 6 comma negative 6 a solution of g of x? So 6 comma negative 6. So 6, 1, 2, 3, 4, 5, 6 comma negative 6, is that a solution? Is that a point on the graph? And we would say, yes, that is a point on the graph. It is there, so it does work there. Okay, so it does work. It is a solution. If I plug it in, it does work. So we'd say yes. Name the two other solutions of g of x. And now in this case here, name two other solutions. I'm going to go ahead and put my points that are at my axis here, x-axis. So I'm going to go ahead and select 3, 0. And I also select this one on the other side, 5, 0. Those are my other solutions for g of x there. And those are our normal type of solutions of where it crosses the x-axis or crosses another point. All right. The descriptive form of parabola, f of x equals a, x minus h squared plus k, this is the vertex form again, is best to reveal the maximums or minimums of f of x without changing the equation. Okay? All right. So that's what we have there for maximum or minimum. Number 2, we're going to want to use this in standard form to complete the chart right there. All right, so to complete the chart, we just plug in these values. To save us some time, I'm going to just tell you what I found when I plugged them in. It's just a lot of work there. When you plug this in, we end up with 4 is 0. We have negative 5, negative 8, negative 9, negative 8, negative 5, 0, 7, and 16. Those are the solutions I get when I plug each x value in to that equation there. Because it's squared, I should have a point here where I notice it kind of stops and it starts to go back the other way, right? You see this is negative 9, 8, 5, 9, 8, 5, 0. So I have that same pattern. So it tells me this is going to be my maximum minimum point right there, or my vertex really. So my vertex in this case is going to be 1, comma, negative 9. We'll have 1, 2, 3, 4, 5, 6. So let's go ahead and do 7, 8, 9. And put that point right there at 1, comma, negative 9. My line of symmetry will be when x equals 1. Now when I graph this, I can go ahead and put my points. There's negative 8, and 0 is negative 8. At 2, we are at, at 2, we're at negative 8. At 3, we're at negative 5. So 1, 2, 3, 4, 5. I'll mirror that over here. And then after 5, we're at 0. At 4, we're at 0. So over here at negative 2, we're at 0. And so we end up with something like this, like so. That's my basic graph there. Explain how I get the line of symmetry from the equation. Okay, so because I'm in standard form, the way I would find the line of symmetry is my x value, I use this equation. X equals negative b over 2a. Just realized there. Did I use on my front side? I didn't. Oh, okay. All right. Sorry about that. Just thought I did something wrong in the initial notes. So negative b over 2a. My negative b is going to be negative and minus 2 over 2. My a value is 1. So minus 2 and a 1. And that becomes a 2 over 2, which equals 1. So I could use the equation negative b over 2a to find this line of symmetry at 1. X-intercept, so where does it cross the x-intercept at? It's going to cross here at negative 2, and over here at 1, 2, 3, 4, positive 4. The y-intercept, we said here, is going to be at when x is 0, so when y is negative 8. So that's my x-intercept, but you also can see right there, it's in the equation already. To factor this, which will help you find your zeros as well, this becomes x and an x. That's that. For the 8, I can use 8 times 1. I could use 4 times 2. I want to be able to multiply something together and then add and subtract the same numbers to get my middle term. So I'm going to use a 4 and a 2. I want a negative 2. So if I put a negative there and a positive there, I end up with a 2x and a minus 4x, which becomes a minus 2x, which matches my middle term. I double check this one, negative 4 times positive 2 is a negative 8, so that's good there. So that's my factored form, which tells me again my solutions, or my zeros, are at x equals 4 and x equals negative 2, which match those 2 points right there, so I know that I've done that right. What is the relations between the factors and the x-intercept? Basically, the factors show you the x-intercepts. Okay? The standard form of parabola, g of x equals ax squared plus bx plus c, is best to reveal the value of the y-intercept without changing the form. Again, we could see that right there in that equation. The factored form is best to reveal the solutions or the x-intercepts, okay, which is what we did here. Our solutions, x-intercepts, are revealed right there when you're in the factored form. Moving down to number 3, it says to sketch r of x equals x squared. So this is a basic kind of graph, or kind of a parent graph here. I can start with 0, 1, and 2. When x is 0, y is 0. When x is 1, y is 1. When x is 2, y is 4. So I could put a 0, 1, 1, 1, 2, 3, 4, and 4. And that's basically what I have here for x squared, y equals x squared. Okay, so that's the first part, my parent graph there. Then it says to sketch the translation such that x of y becomes x plus 3, y minus 1 to create t of x, is what I'm making here. So what we're wanting to do is every value of x, we're going to add 3 to it, and every value of y, we go down 2. So for my first one, if x was 0, I go over 3, 1, 2, 3, and I go down 2, 1, 2. So my new minimum value is right there at negative 3, comma, negative 2. Okay? Now, looking at my parent graph here, I went up 1 over 1, up 1 over 1. Here I went 1, 2, 3, and over 1. So I'm going to go ahead and go 1, 2, 3, and over 1, 1, 2, 3, and over 1. So this new graph would look like this, like that there. So what is the equation of t of x in descriptive form? So what they're asking you to do is to write this as a regular equation. The best way to do this would be to do it in vertex form. So I'm going to say that we already had x squared. What's happening to our x value is x is shifting over to the right 3. Now remember, when we do this here, we want it to be the opposite. The reason it's opposite is because my vertex is going to be a positive 3. So instead of saying plus 3, I have to do opposite when I write the equation. So I get x minus 3 squared, and my y value is just simply the same, minus 2. So my equation would look like this. Again, if you think back to vertex form, that's my opposite as x is at 3, and my y is negative 2, which is where we are, 1, 2, 3, negative 2. So for r of x, which was the first one here, don't get them mixed up, x is decreasing, r of x is decreasing. This thing is decreasing whenever x is less than 0. So from here to here, we're decreasing. And it's increasing whenever x is greater than 0. All right? So that's how we do that, those first 3 there. Let's go to the next page. On the next page, we get to average rate of change. Recall we said at the beginning, our formula for average rate of change is essentially to do y2 minus y1 over x2 minus x1. So what you're going to want to do on these problems here, I'm going to zoom in a little bit. Okay, what we're going to want to do on these problems here, just focus, sorry about that, a little better, not too much, is use my equation, right, to make an x and y chart. And I'm going to use the values x of 2 and 5. So when x is equal to 2, when I plug it in, 2 squared is 4. When x is equal to 5, 5 squared is 25. So now I have my second value and my first value. So I've set it up as 25 minus 4 over 5 minus 2. 25 minus 4 is 21. and 5 minus 2 is 3, and that becomes 7. So my average rate of change from 2 to 5 is 7. On the next one, again, I'm making another t-chart here. X and Y, we're looking at 5 and 8. I already said that 5 was 25, and so 8 squared is 64. Same thing, Y2 minus Y1 over X2 minus X1. 64 minus 25 is 39, and 8 minus 5 is 3. 39 divided by 3 is equal to 13. So my average rate of change on this graph from, if I was to graph this out here, right, because it's going to be curving up really quick there, from here to here, it's like a slope of 5. But from here to here, it's a slope of like 13. It's much steeper, going up 3 over 1. This is up 7 over 1. So it becomes steeper the further I go along on the x-axis, okay? So why is it different? It just means that because this is an exponential equation or a quadratic equation, right, it's going to increase a lot more just because of how that works there. My slope continues to increase the further along I go. All right, let's look for some solutions here. Again, different ways of finding solutions. Some of these are going to be found by just factoring them out to find those simple solutions. Other solutions are going to be found by using the quadratic equation. Okay, so solutions here. We take this, I'm going to factor out a 2 first of all, and I have x squared minus 9. So then I go and say, well, let's factor that out again. X squared becomes x, and an x, and the minus 9 can be a plus 3 and a minus 3. So my solutions for this equation are going to be x equals negative 3 and x equals positive 3. Okay? And yeah, we'll leave it there for now. All right, over here on this next one, I could factor out, this is kind of a weird one here, I can factor a 3 out of both of those. Okay, let's go ahead and do that. If I factor a 3 out, I have 25x squared left plus 16. Okay, now you might stop and say, well, that's easy, that's a square and a square. Okay, well, let's see what happens. If I break that apart, I would have 5x and a 4, 5x and a 4. To make the middle terms go away, I would have to do a positive and a negative. The problem with that is that 4 times negative 4 is a negative 16, and I need a positive 16, which means I cannot factor it this way. That would not work. Okay, so that's not going to work. I could then take a look and say, well, let's set it equal to each other. 75x squared equals negative 48 by moving that over. Alright, so I divide both sides by 75. X squared equals negative 48 over 75. Square root of both sides, but you can already tell there's a problem because I'm taking the square root of a negative number, which means there are going to be no real solutions for letter choice B. For C, we have x squared minus 4x minus 21. I'm going to put an x in the front there. And again, I could look and say, what can I multiply together to get 21 and add and subtract to end up with a 4? I like 7 times 3 because 7 times 3 is 21. Because I want a negative 4, I'm going to make that a negative 7 and a positive 3 so that the negative 7 plus 3 become a negative 4. So I'll write negative 7, I'll write a plus 3, and my solutions are going to be x equals the opposite, 7, and x equals negative 3. For my next one, I'm going to factor out a 2 to begin with. All right, and I have x squared plus 9x plus 20 there. And I'm going to factor that again. I have an x and an x. Again, what can I multiply together to get 20 and then add and subtract to get 9? I could do 20 times 1. That won't get me 9. 10 times 2. That won't get me 9. 5 times 4. I can definitely add those and get 9. So I'm going to add a 5 and add a 4 in order to make that work. My solutions are definitely going to be negative 5 and negative 4. Okay? And right now, as I'm going through this, I just can't think real quick, just like on number 2, or 5a, you have this 2 in the front, so I cannot recall if 0 is a solution. Maybe just check with your teacher on that one for those 2 there. I just can't think about it real quick. I just can't recall. Sorry about that. There we go. Let's go back to E. So E, we have 2x squared minus 15x plus 18. I can't factor 2 out of everything, so I just have to work with what I have. I still like factoring. Some of you guys may like using quadratic equation at this point. I'm just not a fan of that. If I can factor, it's easier for me. So I like to do 2x and x to break that up. Then I ask myself, well, what can I use with an 18 and a combination of a 2 to get up with a 15? My 18 options are 18 times 1. Probably not going to work to end up with a 15. I could do a 9 and a 2. I have a 6 and a 3. I'm going to go ahead and just do a 6 and a 3, and that's because I know that 6 times 2 is 12, and 12 plus 3 is 15. So if I put the 6 over here, I end up with a 12x, and if I put the 3 there, I end up with a 3x. Because I want to combine those and I want them to be negative, I'll make them both negative, so I end up with a negative 15x in the middle, which works out great because negative 3 times negative 6 is a positive 18. So now for my solutions are going to be, and again, if you want to do this the long way, 2x minus 3, you set it equal to 0 to find your solution. I add 3 to both sides, so 2x equals 3. I divide both sides by 2, so x equals 3 over 2. The short way is to recognize that's my numerator, that's my denominator, and I take the opposite value. Numerator, denominator, and it's positive. My other solution here, the opposite of negative 6, is positive 6. So those are my 2 solutions for that one. For f, I'm going to move this negative 10 over to there. So I have 3x squared plus 17x plus 10. And now I'm going to go ahead and factor that out. And I have a 3x on one side and x on the other. Again, I'm back to thinking about I have 10 times 1 as an option, 5 times 2 as an option. I'm going to go ahead and do the 5 times 2 because I have to use this 3. Because 5 times 3 is 15, plus the 2 makes 17, which is what I'm aiming for in the middle. So I'll put a 5 there so it connects with the 3. And I'll put the 2 there because 15 plus 2 makes 17. I want a positive 17 and a positive 10. So those go there. My solutions again are the opposite, negative, numerator over denominator, and then the opposite of that, negative 5. For G, when I looked at this one, I started by going, oh, okay, let's take a look. I've been factoring, it's been working great. Let's do it again. 2x and x. Then I got a 1. I went, uh-oh, that's not going to work because all I can do is 1 and 1. And that's a 2 plus 1 is 3. That's not going to work. So I can't use the factoring method. So I had to go back and use the quadratic equation. Negative b plus or minus the square root of b squared minus 4ac over 2a. I'm going to use the quadratic equation on this one. So my negative b is negative 5 plus or minus the square root of b squared is 25 minus 4 times a times c all over 2 times a, which is 2. So I have negative 5 plus or minus 25 minus 8 is what that is. So I get the square root of 17 all over 2 times 2 is 4. I can't reduce that down anymore, so that actually becomes my solution. Alright, I get negative 5 plus 17 over 4, square root of 17 over 4, and negative 5 minus root 17 over 4. Those become my 2 solutions. Kind of weird, but that's what you end up with. Same is true for letter H, same idea. I can't factor that out, so what I have to do is to put that, the quadratic equation. So I end up with negative 2 plus or minus the square root of 2 squared is 4 minus 4 times 3 times a negative 4 all over 2 times 3. So I have negative 2 plus or minus, and then 2 square root of 4 minus, I have a negative 12 times a negative 4 is a positive 48. 48, that's 48, plus 4 is 52. Alright, and that becomes over 6. Let's erase this space here so I keep using that space. 52 is a combination of, 52 is 13 times 4 equals 52. So that becomes negative 2 plus or minus. If I take the 4 out of that and put on the outside, it goes there. I still have a 13 left under the radical and a 6 there. I don't want to stop quite yet because these can reduce. So it actually goes down and becomes a negative 1 plus or minus root 13 over 3. Okay? So I got to reduce that even further. Moving down to simplifying expressions with negative numbers in the radical. Alright, so 72 is actually 9 times 8 times a negative 1. Okay? 9 is simply a 9 still. 8 is a 4 times a 2, and I still have a negative 1. So now let's pretend these are all in the radical. The square root of 9 is 3. The square root of 4 is 2. The square root of negative 2, of 2 is still 2. And the square root of negative 1 is I. So that becomes 6I root 2. Alright, so we just broke that apart. Let's break this one apart. So I have 96, sorry. 96 can become 32 times 3. 32 can become 8 times 4. And I still have a 3. The 8 can become a 4 and a 2 and a 4 and a 3. And all this I still have with that a negative 1. So I just made a little factor tree here. And I notice I can pull a 4 out with a square root, another 4 out with a square root. I still have a 2 and a 3 underneath the radical, and that little guy is going to become an I. So square root of 4 is 2. Square root of another 4 is 2. I can't do anything without that 2 and that 3, so 2 times 3 is 6. And I still have an I for negative 1, so I'll put that out in the front. Combine 2 times 2 is 4. I root 6 for my solution for letter B. 4I root 6. First C. Look at C here. I'm going to use distributive property. So let's do this here. 4 times 1 is 4. 4 times 2i is 8i. 3i times 1 is 3i. And then 3i plus times 2i is 6i squared. We can combine some terms in the middle. So I have 4 plus 11i. And we said before that I squared equals negative 1. So 6 times a negative 1 is a negative 6. So I actually have 4 plus 11i minus 6. And a negative 6 and a positive 4 come together to make a minus 2 plus 11i for my solution for that one. And our last one on this page here. Again, distributive property, 7 times negative 4 is a negative 28. 7 times 9 is a plus 63i. Over here we get a plus 12i. And then we get a negative 27i squared. So that becomes a negative 28. Combine those together for a 75i. And a negative 27 times a negative 1 becomes a positive 27, negative 28 plus 75i plus positive 27, and a negative 28 and a positive 27 becomes a negative 1 plus 75i for my solution for choice D. Okay, moving on to our last page here for our Unit 12 review. Unit 12 review, okay, we're going to have to complete the square. Remember, our formula for completing the square is first we have to move this number over to that side. And once we move that number to the outside, I'm going to use the formula b divided by 2 squared to find out what value I can add to both sides. So here we go. This is what it looks like. X squared minus 4x is now going to equal, moving minus 6 over, 6. Now I'm going to use my formula, b over 2 squared. b is negative 4. Negative 4 over 2 squared. Negative 4 divided by 2 is negative 2. Negative 2 squared is 4. So what that tells me is I want to add 4 to both sides. X squared minus 4x plus 4 equals 6 plus 4. So now with that in place, I can make this a squared dealio. So I'm going to have x there, and I can have a, oops, not a plus, I want to have a x minus 2 squared. And the reason for that is that negative 2 times a negative 2 is a positive 4. if I was to factor that, work that out, I'd end up with a negative 2x plus another negative 2x for the negative 4x in the middle. That's going to then equal 6 plus 4, which is 10. So for this first part of filling in the blanks, I can write x minus 2 there, and I can put a 10 right there. But I'm not done. It wants me to solve the equation. So to solve the equation, I take the square root of both sides, and that leaves me with x minus 2 equals plus or minus square root of 10. And I want to get the x by itself, so I add 2 to this side. X will equal 2 plus or minus square root of 10. So that becomes my solution for that one. X equals 2 plus or minus square root of 10. For my next one, same idea. I have x squared minus 16x. I'm going to make it equal to 17 by moving the 17 over there. I will use my b over 2 squared. In this case here, b is negative 16 divided by 2 squared. Negative 16 divided by 2 is a negative 8 squared, and negative 8 squared is 64. So I have to add 64 to both sides. X squared minus 16x plus 64 equals 17 plus 64. X, then here, what number can you square to get 64? It's going to be 8. I want it to be a negative 8 because this term right here is negative. Okay, so I have x minus 8 squared equals 17 plus 64, which is 81. Okay, now from this point here, I'm back to where I was in the last problem. I'll take the square root of both sides. The square root of this becomes x minus 8 equals, square root of 81 is plus or minus 9. And in this case here, I will do x equals, add 8 to both sides, 8 plus or minus 9. So for my two solutions, I simply add that up. 8 plus 9 is 17, and 8 minus 9 is negative 1. And those become the two solutions for that equation solved by completing the square. For letters C and D, we're going to be plugging in the ABCs for our quadratic equation and solving it. So we got to do negative b. b is a negative 5. Be careful about that. So I'll put that there. And then negative 5 squared is, well, I'll just write down a negative 5. Plug it in first, sorry. Minus 4 times a is 3, and c is negative 1. And 2 times a is that. Now with that in place, I can go ahead and do my work. So that becomes a 5 plus or minus the square root of 25. And this negative 4 times the 3 is negative 12. Negative 12 times the negative 1 is a positive 12. All over 2 times 3 is 6. So moving this direction, I have 5 plus or minus the square root of 27 all over 6. 37. My mistake, 37. I can't do anything with a 37. It just has to stay what it is. I can't reduce it down anymore. And so that's just what it's going to be, and that's my solution. For D, again, I'm going to do b plus or minus b squared minus 4 times a times c over 2 times a. And this one's not quite as nice. I end up with negative 2 plus or minus the square root of, and this becomes 4 minus, I get 8 times 5 is 40 all over 4. So the problem with this, as you can see, is I have negative 2 plus or minus the square root of negative 36 over 4. Now, you could leave it there and simply say that there are no real solutions, potentially. Okay, I could change this to an imaginary solution, in which case what I would do is I would say, well, this is actually going to be negative 2 plus or minus, okay, this is actually 6i, because this could become 6 times a negative 1, or sorry, 6 squared times a negative 1, right? So 6 comes on the outside, and so does the negative 1 for 6i over 4, which could reduce to negative 2 plus or minus 3i over 2. So I could get a solution with an imaginary number that looks like that, but there really, should be 1. But there really are no real solutions, but if you had to get a solution using an imaginary number, that's what you would do there. All right, moving down to our last one. we have this equation there, and some of the values are on the table for there. So we have k of x and we have m of x, two different equations. All right. First thing I want to do is set up a t-chart for my k of x and y. I notice that my vertex is at -4, 1, 2, 3, 4, and then +2, 1, 2, there, right? So at -4, I'm at 2. And for me, I like to use smaller numbers, so I use -3, -2, -1, and 0 to find some additional solutions for this equation. All right. When I plug those numbers into this equation here, -3, I get 1.5. When I plug -2, I get 0. When I plug -1, I end up with -3.5. And when I plug 0 in, I end up with -6. So I'm going to plot that out real quick. So at -3, I'm at 1.5. At -2, I'm at 0. At -1, I'm at -3.5. 1, 2, 3.5. And at this one, I'm at 6, which seems a little funny, but I'm just going to keep it there. All right, so I end up with something that looks along the lines of that, okay, for k of x. For m of x, they give me the points. At 0, I'm at 5. 1, 2, 3, 4, 5. At 1, I'm at 0. At 2, I'm at -3. 1, 2, 3. At 3, I'm at -4. At 4, I'm at -3. At 5, I'm at 0. And at 6, I'm back up here. So this graph for m of x goes like so. Okay, those are my two graphs that I'm playing with. So now they have a series of questions. I go with this. So the maximum value of k of x, here's my k of x, here's my m, is greater, this value is greater than the minimum value of, m of x. So is that value greater than that one? Yes, that would be true. Next question. The value of x when k of x is at its maximum, so this value of x, which is going to be 1, 2, 3, -4, is greater than the value of x when m of x is at its minimum. Well, here's its minimum. That's going to be 1, 2, 3, +3. So is -4 greater than +3? The answer is no. That is false. Both x-intercepts of m of x are greater than 0. So the x-intercepts are greater than 0. So our x-intercepts are here. We're at 1, and we are at 5. So we're going to say true. They're both bigger than 0. All right. The line of symmetry for k of x is at 4. This is +4. Nope, we're at -4. So that's going to be false. And finally, the y-intercept of m of x here, m of x, is greater than the y-intercept of k of x. Is that greater than that? Yes, that is true. All right, so that's what I got for those solutions there. Again, check with your teacher as always to see what they got. They might have some different answers. And that's it. Hope that helps for that part of the test. Sorry for such a long video. A lot of stuff there.